Hello everyone, we are from Group 16 and my name is AIZUREEN SOFIA BINTI HASLIN. Before we begin, I would like to ask a simple question. Have you ever wondered how Google can find millions of results in less than a second? Or why two people sometimes receive different search results even when they type the same keyword? Today, our group will teach you something that many people use every day but may not know much about it, which is how search engines use logic and set theory behind the scene. Although search engines look simple, they actually rely on mathematical concepts to organize, filter, and display information efficiently. Search engines process billions of searches every day and help people find information within a second. They do not search for information randomly, but use mathematical methods to collect, organize, and rank billions of web pages. By using logic and set theory, search engine can identify relevant information and filter out unnecessary results. This mathematical concept allows search engines to provide fast, accurate, and personalized search results for users around the world. So, what is exactly a search engine? A search engine is a software system that helps users find information on the internet. Some common examples are Google, YouTube, and Bing. Whenever we type a word, phrase, or question into the search bar, the search engine quickly searches through its database and provides the most relevant results. It works through four main processes. The first process is called crawling. Search engines use automated programs called crawlers or spiders to visit websites and collect information from them. The second process is indexing. The collected information is then stored and organized into a large database so that it can be retrieved quickly later. The third process is processing, queries. When user types a search, the system analyzes the keyword and tries to understand what information the user is looking for. The final process is ranking results. The search engine evaluates many factors and decides which web pages are the most relevant before displaying them in order. Without this process, it would take a very long time to find information online. That is why search engines are very important in our daily life. Next, my group member will explain how search engines apply Boolean logic and set theory to filter and organize information more effectively.
Hi, my name is HASLIN. Today I would like to explain the logic behind the search engine. So for the search engine is rely on two things. First, Boolean operator, and the second one is the set theory. For the set theory in math, this is a universal set which is represented by a big capital U which represents every single thing. So for the set engine, it represents the entire database of index web pages. Every time we type a query, we are trying to filter down this massive universal set into specific subset of the answer that actually we want.
Moving on to the Boolean operator, there are three Boolean operators that use search engines, which are AND, OR, and NOT operators. For the AND operator, it is known as intersection in the set theory and known as conjunction in mathematical logic. The purpose of the AND operator is looking only for the information where both conditions are absolutely true. Let's put that into a real-world scenario. Imagine we are looking for a new phone and we search for iPhone 17 and the Pro Max. The search engine will think of set A as all the iPhone 17 and set B as all item labels Pro Max. Let us look at the picture of the universal set. The result is the overlapping middle section of those two groups where both conditions are strictly met. So the result will return iPhone 17 Pro Max. So the job for the search engine is help us narrow down the gigantic universal set to specific overlapping region. That's why we need to adding more keywords that help us to get more specific result. To the OR operator, also known as union. Now we don't want to narrow things down. We can use OR operator to expand our search scope. It is highly effective for gathering synonymy or broadly the related concept. It's 5 pages containing any of the specific terms. That means the entire area covered by the bond set is retrieved. In this weekend, we want to see a movie. We search for comedy or action movie on the Netflix. This includes the union of two sets. set A for all comedy movies, and set B for all action movie. As long as movie belong to set A or set B of both like action comedy, it will show up. So it helps us to expand our potential choices. For the NOT operator, the NOT operator is applied to exclude unwanted interference. It is useful in advanced search syntax like using the minus signs. It actively exclusive the pages containing a specific terms, leaving only the relative complement. For example, think of an allergic foodie. Suppose we are ordering a delivery, but some of us are allergic to seafood, so we search spicy minus seafood. From a set theory perspective, we are calculating the difference between two sets. Set A is all spicy food and set B is all food containing seafood. So the result will return the strictly subtracts set B from set A, so we only get the spicy food that not containing seafood. Now I will pass to my teammate to explain the filtering system.
Hi, my name is SITI SOFIA. Now, I will explain filtering systems, a mathematical example, and the importance of logic and set theory in our daily life. First, what is a filtering system? A filtering system is a process used by digital platforms to select and display information that match a user preference or requirement. Many popular applications use filtering systems such as TikTok, Netflix, Spotify, and Shopee. Now, for example, when you shop on Shopee, you can filter products by price, ratings, brand, or free shipping. Instead of showing thousands of products, the system only displays products that meet your selected conditions. Similarly, TikTok and Netflix use filtering on your interests. They analyze your viewing history, likes, shares, and interaction to determine what content you are most likely to enjoy. Next, let us look at a simple mathematical example. Consider the recommendation rule, open bracket P and Q cross bracket or R, where P, price is less than 100 ringgit Malaysia, Q, rating is greater than or equal to 4 stars, R, free shipping is available. This means a product will be recommended if it satisfies both P and Q, or if it has free shipping. For example, suppose a product costs 80 ringgit Malaysia and has a rating 4.5 stars. P is true because 80 ringgit Malaysia is less than 100 ringgit. Q is true because the rating is above 4 stars. Since both P and Q are true, the product will be recommended. Now, consider another product that costs 150 ringgit Malaysia and has a rating of only 3 stars, but it offers free shipping. In this case, P is false and Q is false, but R is true. Because the rule is open bracket P and Q close bracket or R, the product can still be recommended due to the free shipping condition. This example shows how logical operators help system make decisions automatically and efficiently. Finally, let us discuss the importance of logic and set theory. Logic and set theory are fundamental concepts in mathematics and computer science. They help computers process information, organize data, and make decisions. Search engines use logic to find relevant information. Filtering systems use set theory to narrow down search results. Recommendation systems use logical rules to suggest products, videos, and movies that match user preference. Without these concepts, modern technologies such as Google, TikTok, Netflix, and Shopee would not be able to provide accurate and personalized results. In conclusion, logic and set theory are not just theoretical concepts studied in mathematics. They play an important role in many technologies that we use every day. From searching information online to receive personalized recommendations, these concepts help make our digital experience faster, smarter, and more efficient. That's all. Thank you for listening.